Hello and welcome to CSCult, and in today's video we're going to discuss about the easy problem of bits of module 1, and the problem is sparse number, and the problem statement is as follows. We're given a number n, and the task is to check whether it is sparse or not, and a number is said to be a sparse number if no two or more consecutive bits are set in the binary representation of the number, right? So we have to check if the given number n is a sparse or not, and a sparse number is a number whose two consecutive bits are not 1, and if two consecutive bits are 1, then it is not a sparse number. So let's see this examples. So we have a binary of 0 as 0, so 0 is a sparse number, and we have binary of 1 as 0 0 1, so it is also a sparse number, and we have binary of 2 as 1 0, so it is also a sparse number, and we have binary of 3 as 1 1, so here two consecutive bits are set, so this is not a sparse number. And now after that we have 4, which is a sparse number, and we have 5, so 5 is also a sparse number, and then we have 6, so in 6 there are two consecutive bits which are set, so this is not a sparse number. And we have 7, and there are three consecutive bits set, so this is also not a sparse number. Then we have 8, so 8 is a sparse number. Then we have 9, so 9 is also a sparse number. Then we have 10, and 10 is also a sparse number, right? So how are we going to solve this question? So let's talk about the naive approach first, which is the most basic approach we can think of if we don't know bit manipulation or anything about bit. So what we are going to do is we are going to store the bit representation of these numbers in a array. So we're going to create an array of length 30. I'm just going to use the last 4 as we have binary representation up to 4 digits, right? So this is of length 32, right? So what we are going to do is we are going to store this binary representation in this array. So let's say we have n equals to 3, right? We are going to talk about n equals to 3. So for n equals to 3, the representation is 0 0 1 1, so we're going to store 0 here, we're going to store 0 here, we're going to store 1 here, we're going to store 1 here, right? First we are going to initialize this array with 0 to avoid any garbage value error or something like that, right? So after that we're going to store the bit representation of this number particular n in this array, and for this array we're going to traverse from the left right side, and we're going to check if there is two consecutive ones in this array, and if there is two consecutive ones, then we're going to return false, and if there is no two consecutive ones in the array, we're going to return true, right? For this we have two consecutive ones here, so we're going to return false here, right? So this is how we're going to solve this question in naive way. It is the brute force approach for solving this question, right? So now let's talk about the efficient approach. So for the efficient approach, we're going to use right shift operator, right? This is a bit manipulation operator. This is under the bit manipulation section, and we're going to use this operator to solve this question efficiently. And what we are going to do is we're going to check if n and right shift 1, if this value is 0, then our answer is true, that our number is a sparse number, and if this value is 1, so our answer is false. So if this value gives true, this value gives 1, so our answer is false, else our answer is true. I'll explain this in a bit. Else if it gives 0, our answer is true. So what this particular statement do is, let's talk about 3 or let's talk about 1, right? So we have 2, sorry, we have 2, and binary of 2 is 0 0 1 0, right? And what if we do 2 right shift 1? So right shift is basically 2 divided by 1, right? This is sorry, 2 divided by 2. This is the right shift operator, right? You must have learned this about right shift and left shift. So we have n right shift 1, so we will have 2 divided by 2 to the power 1, which is 1. So what this will give us, it will give us the binary of 1. So this is our 2 right shift 1. So now what we're going to do is we're going to AND this two numbers. So the AND of this two would be 0, right? So this will give us 0. So if we have 0, then the answer is true, the number is a sparse number. And now let's talk about a condition where the number is not sparse, right? So we have 3. So the binary of 3 is 0 0 1 and 1, right? And the And now what we'll do is we'll do 3 right shift 1. So the value of 3 right shift 1 would be 0 0 0 1. So what we do in right shift is we will shift the bits towards right. So if we have 0 0 1 0, so the right shift of this would be 0 0 0 1. We are shifting this bit here, and we're going to shift take one bit from the left side. There are this is 4, so there are 28 zeros here, right? So we're going to take 1 0 from the left side, and we're going to use this as this 0 here, right? So this is the value for 3 right shift 1. Now we're going to perform the AND for these two numbers. So the AND of this two would be 0 0 0 and 1. So this is not 0, so our answer would be false, that the number is not a sparse number. So this is how our solution would work. Now let's take another example. Let's take 9. So the binary of 9 is 1 0 0 1, and 9 right shift 1 would be what we have. We will have 1 0 1 0 0, right? So the AND of this two number would be 0 0 0 0. So this is 0, so this is a sparse number, so we're going to return true, right? So this is the basic idea of solving this question efficiently. So because the naive approach will take space and time as well, right? So this was the efficient approach where we are going to use right shift operator, and what we're going to do is we're going to bitwise AND of n and n right shift 1, right? Now let's see the code for the efficient approach. So here's the code for the efficient approach. So what we are doing here is we're going to check if n and n right shift 1 is 0 or not. If it is not 0, we're going to return false, and if it is 0, we're going to return true. This condition is only valid if the inner part is 1, right? So if it is 1, we're going to return false for this condition, and if it is not 1, we're going to return true. So this was the naive approach. Let me just write this part once more. So we have if n and n right shift 1. So if this part gives 1, so we are going to return false, right? And after completion of this, we are going to return true if this does not give us true, so we are going to return true. So this is how we are going to solve this question efficiently. Thank you.